Hi, welcome to another edition of Math Tutorials by Bob Pryor. Today we're discussing section 4.4, Multiplying Binomials. I'm going to give a brief introduction though about multiplying polynomials in general like we did in section 4.3, and I'm going to take a simple polynomial like x plus 2 and multiply it by a trinomial, say x squared plus 5x minus 3. And as I do, I'm going to remind you that we distribute the x through to each one first, and then we'll distribute the positive 2 through to each of these three terms. And notice that we're going to get 6 products out of this. Let me just make a note of that. We get 6 products. And for these 6, I'm going to write the first 3 in red, which is x times x squared is x cubed. X times 5x is 5x squared. X times a negative 3 is a negative 3x. And then in blue, I'm going to put them in their like term positions. First is 2x squared, so I'll put it underneath here, and that's a positive 2x squared. And let's see, 2 times 5x is a positive 10x, and 2 times negative 3 is a negative 6. So when we add these all together, we get x cubed plus 7x squared plus 7x and minus 6. But the key here is that we start with these 6 products. That's what we get to start with. 3 here and 3 here. And we're able to combine them into less than 6, but we start with 6 products in all. And that's because we have a binomial. You know, you think about 2 terms times 3 terms, and that gives us a total of 6 terms to start with. Okay? That's a brief introduction. For multiplying binomials, I just may as well conclude this. And we'll take, for example, x plus 2 times, let's say 4x plus 5. We're going to get 4 terms to start with. In this case, distribute the x to each one. We'll get 2 terms that way. And then we'll distribute the 2 to each, and we'll get 2 more terms, a total of 4 terms. And that'll look like this. X times 4x is 4x squared. X times 5 is plus 5x. 2 times 4x is 8x, positive 8x, and 2 times 5 is a positive 10. And these 2 middle terms happen to be able to combine, so we get end up 4x squared plus 13x plus 10. And that's an introduction to what we're going to talk about today. Let me erase all of this and refer now to page 4.4-1, where we happen to have this product, 2x plus 3 times 4x plus 5. And as I suggested, we'll get 4 products. 2x times 4x. And then 2x times 5. 3 times 4x. And then 3 times 5. The reason I made these different colors is I wanted to point out something to you about a binomial times a binomial. And this is true for binomial times binomial only. We get these 4 products. And we can think of 2x times 4x. We can think of 2x as the first term in here, and 4x in the first term in this one. And so, in a sense, this first product is a product of firsts. Secondly, we can think of the 2x times the 5 as a product of the outer terms. These are the farthest away terms, kind of the outer of these, and so we'll consider that the outer product. Similarly, the 3 and the 4x are like inner terms. So we'll consider their product the inner product. And to complete this, we'll consider the 3 times the 5 as the last of each binomial. The 3 is the last one here, the 5 is the last one there, and so we'll consider this the product of the lasts. And we'll write it that way. Whoops, excuse me. Lasts. So what it is that we get in all of this is the firsts plus, that's the first product, the outer product plus the inner product plus the last product, or the product of the lasts. And we abbreviate this as FOIL. FOIL, FOIL. And we call this FOIL method. Now, the truth is, we don't need the FOIL method because we've learned that we distribute 2x times the first, 2x times the second, 2x times 4x. In fact, let me just go ahead and write that out. 2x times 4x is 8x squared. 2x times 5 is a positive 10x. And then 3 times 4x is a positive 12x. And 3 times 5 is positive 15. And we've learned that we can combine the middle terms if they're like terms. We can. And we get here 8x squared plus 22x plus 15. But this FOIL method allows us to talk about these different products, and we certainly will need to in Chapter 5, especially starting with Section 3 and 4, I believe. We'll need to talk about these, and so this FOIL method gives us a nice way to talk about the different pieces, the different components of this product when we multiply them out like this. Down here they'd show up with firsts being 8x squared again. The outer being 10x. Oh, positive 10x, excuse me. The inner being a positive 12x, and the last being a positive 15. Sometimes, as we had noted already, we can combine these terms. Sometimes we can't. But in this case we can, and we would get it down to 3 terms. Here plus 22x plus 15. Same thing we got over here. But this FOIL method, like I said, allows us to talk about this product of 2 binomials, you know, in a nice way. And like I said, I'll be using it throughout this section 4.4, but also in Chapter 5. Let me go ahead and erase and do an example. Here I'll do example 1 on page 2. So now we're looking at section 4.4, page 2, at example 1. And I want to do 1A and then 1B and then example 1C. So let me start with 1B, which says 2x minus 3 times 6x minus 5. If we consider these 4 products, FOIL, then we're going to be able to just think about them sometimes and write them down quickly without having to show all the lines. The firsts is the 2x times the 6x. So that's 12x squared. The outer product is the 2x times the negative 5. The outer product, negative 10x. The inner product is the negative 3 times the 6x, negative 18x. And the product of the lasts, or the last product, negative 3 times the negative 5 is a positive 15. In this case, the middle 2 terms are like terms, so we can combine them, and we get 12x squared minus 28x plus 15. The FOIL method also just helps us remember that we need to have 4 terms, and so it kind of helps us guide us to get those 4 terms. Let me then now do example 1C, which is x minus 5 times 2x squared plus 4. Make sure I wrote that down correctly. Yep. And if, again, we look at the 4 products, FOIL, we're going to see something a little bit different here. The first thing we'll notice is that x times 2x squared is 2x cubed, which over here our first product was an x squared. Well, this one down here is an x cubed, so that's a little bit different. The outer product is x times 4, which is a positive 4x. The inner product is the negative 5 times 2x squared, negative 10x squared. And the last product is negative 20. Well, one thing I want you to notice here is that this time the middle two terms are not like terms, and so they can't be combined. Furthermore, to put things in descending order, we want to really have the 10x squared term, really negative 10x squared, written in the sum followed by the 4x. Because 2x cubed is the highest, we're going to write it in descending order and get it to be 2x cubed minus 10x squared plus 4x and minus 20. And now it's complete. It's in descending order. There are no like terms to combine, and it's complete. So sometimes we'll get the middle two terms, and oftentimes it would be the middle two terms, the outer and inner product, that would combine to become one term because they're like terms. But down here we didn't. What's the key? What is going to tell us whether or not we're going to get 2 terms or 3 terms? Excuse me, I didn't mean to say it that way. I meant what tells us whether we're going to get the middle terms to combine to one term or not. Maybe they'll be different. And the key is in the binomials here. Notice when the first terms are of the same degree. Here they're both the power of 1, we'll be able to combine the middle two terms. Get a trinomial in the end. Here the degrees are different. Here's the degree of 1, but here has a degree of 2. And when they're different like that, we are not going to generally get 3 terms. We'll generally get 4 terms where we won't be able to combine the middle two. Now that can change, so don't rely on that as a general rule. Instead, treat each problem separately, but that's a key to look for that. And then when they don't combine, we want to make sure that everything is written in descending order. So it might take one more step beyond just the FOIL. Okay? Let's take a look now at example 2. Actually, there isn't a specific example 2, but instead kind of an explanation of how sometimes under special circumstances we could do some of this just in our heads, mentally, in one step. In other words, we could skip the middle step where we have 4 terms. And that is going to be so if these first terms are like terms. In this case, they're both x terms, something x to the first and x to the first, that we're going to be able to combine the outer and inner products. And so I'm going to encourage you to think about these and do this in one step, going from binomial times binomial to the ending trinomial, recognizing that the outer product and the inner product are going to be the same, meaning, I shouldn't say the same, but they'll be like terms, and we'll be able to combine them. The key here is to keep things in a straight, but I'll use FOIL, and we'll keep things here mentally and think about it. But if it doesn't work for you to do this in one step, then don't. Take the time to get all 4 products and then combine like terms as you're able to. So let me go ahead and do a couple of focus exercises on page 4.4-8. So page 4.4-8, I'm going to do some focus exercises. And this comes from number 2. And I'll show you what I mean by doing these things in just one step. We'll start off simply with letter B, which says we have x plus 9 times x plus 6. And we're going to do this in one step by thinking about what's the first product. First, x times x, x squared. Now it's the middle two terms, the outer and inner product, that will be like terms because these are both degree 1. It's x to the first power and x to the first power. When we multiply the outer, and we're not going to write this down yet, but we get 6x. 6x. Do you agree with that? Good. The inner term is 9x. That's a positive 6x and a positive 9x. Now think about it. Positive 6, positive 9, so positive 15x. Positive 15x. Don't forget the x part of that. And then the last is just the constant 9 times the constant 6. 9 times 6, positive 54. And there we get the trinomial in just one step. All right? That's the key for, that's what I want you to do in focus exercise 2 and also in exercise 2 in the body of the problem set. But if you can't do it in just one step like that, you can't do it mentally, that's okay. Take your time and do it in more steps. But I'd like you to be able to do it that way. Let's do example D. I'm sorry, focus exercise D, which says we have x minus 6 times x minus 4. Again, using the FOIL method, the firsts, it's x times x, simply x squared. The outer product, here we go, negative 4x. Negative 4x. Keep that in your mind, negative 4x. The inner product is negative 6x. Keep that in your mind. Negative 4x, negative 6x, negative 4, negative 6 is negative 10x. The lasts, negative 6 times negative 4 is a positive 24. Okay, let's choose a different example. How about letter J? J is kind of interesting. Letter J says we have x minus 10 times x plus 10. This one is interesting because, and I shouldn't have made that an equal sign there. I'll just get rid of that. But this is going to be equal to now x times x, first, x squared. The outer product is positive 10x. Positive 10x. The inner product is negative 10x. Now in this case, a positive 10x and a negative 10x, they're opposites, and they add to 0. Now I could write a 0x term here, or just 0. But the truth is we don't need it. We don't need it at all. In fact, this is a time when that middle term is gone completely. And we'll end up now with the last, negative 10 times positive 10 is negative 100. Here we get just a binomial. It's because the outer and inner products were 0. They added up to 0 when they combined. Positive 10x and negative 10, they were opposites is what I should say. Okay, good. Let's take a look now at example, or exercise P, which says we have 7x plus 1 times 2x minus 3. And again, using the FOIL method allows us to think this through. The first product, that's the 7x times 2x. 7x times 2x, 7 times 2, 14x squared. Good. Now, we got to do some thinking here, and we're going to have to retain this in our heads here. 7x times the negative, that's the outer product. That's a negative 21x. Negative 21x. Think negative 21x. Okay, we'll put that in the side of our brain. A little more to the right. Okay, there you go. And then here, inner product is positive 2x. Let's fish it out now. Negative 21x, positive 2x. It's going to be something x. Negative 21, positive 2. Negative 21, positive 2. Negative 19x. Negative 19x. Good. Got to complete this. The last term, 1 times negative 3 is negative 3. As far as the FOIL method is concerned, here's what we've done. First, outer plus inner, and lasts. That's the mental process of the FOIL method. First, outer plus inner, and lasts. Same thing here. First, whoa, last. Remember, the outer plus the inner became 0, or 0x. And we didn't need to see it at all. So here we just got firsts and lasts. Won't happen often. Don't rely on this first and last. It happens only when the outer and inner product add up to 0 because they're opposites. Positive 10x, negative 10x. So rarely would we get two terms, but it does happen. And here again, first terms, this is the outer plus the inner, and then the lasts. Okay? That's all there is to multiplying binomials. If you can't do it in one step like I did here in this set of examples, that's okay. Just go ahead and work it out as you need to. But if you're able to, that's terrific and will make you stronger in multiplying these. But again, check your work, check your answers, make sure you're doing things correctly. That's all I have for session 4.4. I hope this has made some sense. Please send me an email or send me a discussion board message for me to answer or for other students to answer. And do the reading. Even though I did most of this, still do the reading to make sure it makes sense. All right? All right. Next, 4.5. I hope that's coming up soon for you.